So we've looked at the basics of complex numbers, introduced them, where they've come from and the ideas behind them. What I'm going to do here, I'm going to show you a couple of questions looking at the operations involved in them. I want you to read the questions, pause the video, have a crack at them, then come back and check your answers with the work and I'll present here. So here you go. First one, I'm giving you two complex numbers here, Z1 and Z2. I want you to perform these three calculations with them. Second one, I've given you a quadratic here. I want you to solve it and give me the answer in the form of a complex number, Z equals A plus BI. So pause the video and have a ping at those. So the first one, I've got Z1 equals 1 plus 2i and Z2 equals 2 minus 3i. First thing I'm going to calculate is Z1 plus Z2. So if I do Z1 plus Z2, that means I've got my 1 plus 2i, adding on the 2, take away the 3i, the second imaginary number, second complex number. Remember we said group the real parts together, group the imaginary parts together and solve it from there. So the real parts, I've got 1 plus 2, and then the imaginary parts, I've got plus 2, take away 3 times the I. So what that then gives me is 2 plus 1 is 3, 2 take away 3 is minus 1, so I've then got minus I. Second one was this calculation here, so 2z1 take away 3z2, so we can subtract them, we've covered that already, but 2z1 is simply 2 times that, and 3z2 is simply 3 times that. So that would be our first step, our first protocol. So 2 times 1 plus 2i is then going to be take away 3 times 2 minus 3i. So what I then end up getting, multiply all these out, I get 2 plus 4i, take away 6, plus 9i. And then it's just the same as before. Group the reals, group the imaginaries, simplify it from there. So I've then got 2 take away 6 from my real part, I've then got plus 4, plus 9 from my imaginary. Simplifying those, I get negative 4 plus 13i. Final one was multiplying the two of them together. So again, think back to how we did it, write the two brackets, multiply it out like a quadratic, and then simplify it all down. So I've got 1 plus 2i there from my first imaginary number, and I've then got 2 take away 3i from my second complex number. So it's then multiplying it out using FOIL like we would a quadratic, and then simplify it together. So I get 1 times 2 is my first part, so I get 2, I've then got 1 times negative 3, so I've got minus 3i, I've then got 2i times the 2, so I've got plus 4i, I've then got plus 2i times negative 3i, that gives me negative 6i squared. Now remember, the I squared is negative 1, so that's negative 6 times negative 1, so I can write that out as 2 take away 3i plus 4i plus 6. Minus 6 times minus 1 gives me plus 6. Then, same as before, group the real, group the imaginary, see what we get from there. So I've got 2 plus 6 there, and then adding on, I've got negative 3i plus the 4i there. 2 plus 6 is 8, negative 3 plus 4i simply gives me a plus I. So I've got 8 plus I for that final solution there. So the three basic operations, add, subtract, multiply, that we've looked at, there's another example for you with a pair of complex numbers. The second question was solve this quadratic here, z squared plus 2z plus 6 equals 0, giving your answer in that format there. Now remember, when we've got one like this, what we said we do is we use the quadratic formula. So in this case, I know that z is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Formula that we know and we love. We then have to figure out the a, b and c and substitute them in. So in this case, I get negative 2, there's my b. It's then plus or minus the square root of b squared, so that's 2 squared, which is 4. Take away 4 times a times c, so 4 times 1 times 6, so it's then take away 24 all over 2 times a, which is just 2. What I then do is simplify it down and see what I can get from there. So I get negative 2 plus or minus the square root of negative 20 all over 2. Now let's focus on the negative 20 to begin with. So square root of negative 20, that's the equivalent of the square root of 20 times the square root of negative 1. Always take that out first. Now square root of 20, we can't write an exact integer answer to that, but we can simplify it like a third. Square root of 20 is the equivalent of root 4 times root 5, which is there for the equivalent of 2 root 5. So my square root of negative 20, I can rewrite it as negative 2 plus or minus 2 root 5 times I all over 2. Remember, your coefficients can be rational, irrational, any real number you want. What I then do is split it up by dividing both terms here by 2, and I get my two solutions. So I get solution 1, so I get z equals negative 2 over 2 plus 2 root 5 over 2 times I, which in this case is negative 1 plus root 5i. And my second solution then comes from the subtraction version of this. So I get my second solution as z equals negative 2 over 2, take away 2 root 5 over 2 times I. So that would then still give me negative 1, but this time it's going to give me take away 5i. So there you go, I've got two solutions there. So I've got my two solutions for the quadratic using the quadratic formula in the format of two complex numbers. So we have to bear that in mind. It's the same steps as before. Just remember that formula that we covered a couple of years ago. Go back and refresh your memory if you need to of it. There's the basic operations. Add, subtract, multiply, divide, solving a quadratic, bringing in complex numbers and seeing how we can use them for it. Very useful, and you can see why it was an important discovery that they came up with.